Okay, so now this piece is about ij form of vectors. Now, ij form of vectors may seem kind of silly because we already have component form of vectors, and it's really the same thing, just another representation. Really, ij form, to me, the reason I like it so much is because it turns it completely into an algebraic expression. So instead of looking like coordinates, it looks like a normal equation, something we're used to dealing with combining like terms and all that. So it makes it easier when you're adding, subtracting, it just feels like normal algebra again. So component vectors, this works the same as it did before. We have initial point P, terminal point Q. We always do the terminal point minus the initial point. So essentially, we're doing Q minus P in order to find the horizontal and vertical movement. Like before with component vector, we just did our little pointy bracket, did 5 minus 3, so we know the horizontal movement is 2, 6 minus 2. The vertical movement is 4. There's our component vector. So now to write that in ij form, super simple. It is just 2I plus 4j. All that means is I, any number, whatever's with I, that's how far you're moving horizontally. Whatever's with j is how much you're moving vertically. So like if I was just given that 2I plus 4j vector, and I wanted to draw it, I know I is horizontal, so it'd be over 2, 1, 2. I know j is vertical, so up 4. I guess I could have done that here. And then that 2I plus 4j vector would be this green vector in my drawing. So it is just the same as writing it as coordinates. It's just now we have an algebraic expression to show that vector. So now for number 2, same deal we do. 6 minus negative 2, my horizontal movement, 6 plus 2 will be 8. And we have negative 2 minus negative 1, so negative 2 plus 1 gives us negative 1. So this vector in ij form would be 8I, because that horizontal movement was 8, minus 1j, because the vertical movement was negative 1. And just like in normal expressions, you don't have to write the coefficient of 1. So now that last part says, now add these vectors together, essentially the resultant of these two vectors. Well, all we have to do. So if we want to do 2I plus 4j, we want to add that vector with 8I minus j, essentially. There's my two vectors in the parentheses. It is just normal algebra, and that's why I like ij form so much. You are legitimately combining like terms. The i's go together to equal 10I. The j's go together to be, well, let's keep the same color the same, plus 3j. So this would be the resultant of the vectors in 1 and 2. Horizontal component of 10, vertical component of 3. So again, component form, ij form mean the exact same thing. It is just two different ways of writing it. One looks more like coordinates, so you're thinking about it on a coordinate plane. One of them goes back to algebra, so it really takes you into that algebra mindset.